Let's look at number 18 and 19 on Monday's study guide. So number 18, you have a flagpole. The flagpole is 7.2 meters, and the wind is pulling the flagpole that way with a force of 52 newtons. And it says, what is the torque? Well, I have two formulas to choose from, and I'm not sure which ones I should choose. Are they talking about angular acceleration or moment of inertia? No, this thing is not moving, so it's not experiencing any acceleration. What other one can I use? Let's see, no torque, no torque, torque. Here's another one with torque. Force times radius. Do I have a force? 52 newtons. Do I have a pivot point? Imagine this is the flagpole. It can pivot this way. It doesn't pivot, but it can if we want it to. So we're going to solve this problem using torque, and it's simply torque is equal to force times radius is equal to 52 newtons times 7.2 meters is equal to 374 newton meters. That's number 18. Number 19, you have a disc, and you're going to pull on the disc to make it spin. It says, what is your angular acceleration? Okay, so they're asking me what alpha is. Alpha is question mark. What are you given? Mass is equal to 5 kilograms, and torque is equal to 78 newton meters. Which formula can I use here? Well, that doesn't have anything in it. Torque is equal to I alpha. That kind of works. Here's another alpha. This is change in velocity over time. I don't have velocity or I have time. This one might become more useful. Let's have a look at it. Torque is equal to I. Okay, we said that this is a disk. So if I give you an idea of disk or globe or something like that, you should immediately turn to your book and look up the different shapes. And this shape, it has an I that's equal to 1/2 mv squared. So its moment of inertia is 1/2 mv squared. So T, I can use this, T is equal to I alpha. And they're asking for this. I basically have that. Let's rearrange this. Let's divide each side by I. Torque over I is equal to alpha. Torque, I have. I can still calculate. Torque, the I in your book is equal to 1/2 mv squared. I'm sorry, not mv squared, mr squared. My mistake. Is equal to 78 newton meters over 1/2 times 5 kilograms times, let's say, oh, I didn't give you a radius on this disc. So let's say this radius is 2 meters. So this is going to be times 2 meters squared. So we have 78 times, 78 divided by, I put a parenthesis, 0.5 times 5 times 2 squared, close parenthesis, and I've got 7.8. What units? I don't even know. This is going to be lambda meters squared. This will cancel with this. So I have newtons, kilograms, meters. Newtons is the same thing as kilograms, meters per second squared over kilograms, meters. Kilograms cancel, meters cancel. I'm left with something over second squared. Well, if it's blank over second squared and we're talking about angular movement, we're going to say that can be filled with radians. So this is your answer. Sorry for leaving out the diameter there.